Alright, and welcome to solving logarithmic equations. Now in example 1 we have this. 2 is equal to 9 log base 8 of x minus 25. Now let's go ahead and write our trusty PEMDAS over here to the side. Remember, all of algebra is essentially just solving in the opposite order of our order of operations. So let's kind of see what things do we have here. Well, this logarithm is essentially going to serve as our exponent. This 9 serves as our multiplication, and of course this minus 25 will serve as our subtraction. Alright, well, how in the world do you get rid of subtraction? You get rid of subtraction by addition. So let's add 25 to both sides. Now, of course, that zeroes out, and 2 plus 25 is 27, is equal to 9 logarithm base 8 of x. Well, from here, we'd say, okay, well, how do I get rid of my multiplication? And we get rid of multiplication by using division. 27 divided by 9 is 3. And so at this point, we have 3 is equal to the logarithm base 8 of x. Now, I think this is probably one of the more unusual things that you'll see. But remember, a logarithm is the opposite of an exponent. So when I see that I have a base of 8, what I want to do is I want to take the log base 8, and I actually want to put it into the exponent of 8. Let me say that one more time. This logarithm has a base of 8. Since a logarithm is the opposite operation of an exponent, I'm going to put this logarithm inside the exponent of this base of 8, and what happens is these two things cancel. Now, what I do to the right, of course, I have to do to the left. So really what I have is, let's bring this x over, we have x is equal to 8 to the power of 3. Now really that's like saying 8 times 8 times 8, but let's go use our Desmos scientific calculator. We can type in 8, and then what we'll do is we'll push this little a to the b, and then what we can do from there is we'll go ahead and type in the 3, and of course you can see the answer is 512. So we can see that x is equal to 512. Alright, let's go ahead and take a look at one more example. Pause the video, finish taking notes, and let's move on. Okay, here in example 2, we have 3 log base 4 of x minus 9 is equal to 3. Well, notice we have some subtraction here with the minus 9. We have our multiplication with that 3, and this logarithm base 4 is going to serve as our exponent. Okay, so what in the world do we do? Well, let's first get rid of our subtraction by using addition. And we can now say, okay, we have 3 log base 4 of x is equal to, well, 3 plus 9 is, of course, 12. Here, let's get rid of our multiplication. We can divide both sides by 3. And now we have this. We have a log base 4 of x is equal to 12 divided by 3 is, of course, 4. And lastly, remember, this is our tricky part. How in the world do you get rid of a logarithm? Remember, a logarithm is the opposite function of an exponent. So if we have a logarithm base 4, we're going to raise up everything into the exponent of the number 4. So 4 raised to the logarithm base 4, those two things cancel. We're left with x equals, and what we do to the left, we of course do to the right. And 4 to the power of 4 is really like saying 4 times 4 times 4 times 4. Okay, now if you knew that 4 times 4 and 4 times 4, that would be 16 times 16. If you knew that that was 256, that'd be pretty easy. But let's use our Desmos calculator. We can go ahead and delete everything. Let's see here. And we can go ahead and say, okay, we have 4. Oh, I'm sorry. Sorry, that's so annoying right there. But we can say, okay, we have 4, which we will raise to the power of, get rid of that, 4. And y'all can see the answer, of course, is 256. Alright, I hope this helps, and I'll catch y'all in our next video.